Hi there. This is ArcGIS Runtime Routing and Navigation Tips and Tricks Demo Theater. I'm Frank Kish and I'm Product Engineer on the Network Analyst team focusing on ArcGIS Runtime. So the topics we're going to cover today are using the Network Analyst API, mainly focusing on routing. And then we'll look at the Navigation API, which helps track your location along a route. And finally, we'll also look a little bit at some related topics such as route layers and location data sources. During the presentation, I want to highlight some of the areas of the API we either get questions about or some of the areas that are a little non-obvious how they might be used. I'll be switching back and forth between slides and demos. And just to note, the demos will be in .NET, but they're related. The concepts are applicable to all the SDKs. So let's get a quick overview of the Network Analyst API. This API has three tasks: route, close facility, and service area. And each task follows a similar programming pattern. So once you know one, you kind of have a good understanding of them all. And that pattern is to create a task object, and that task object is based upon some sort of underlying network data set, either local or a service. Then you create a default parameters object from that task object, and that parameters object's values will be based upon the network data set that the task object is pointing to. You then update that parameters object by adding in inputs, and you can change the default values. And then you solve and you create some sort of result object, be it a route result or a service area result or a close facility result. So the tasks themselves are created, as I said a moment ago, about pointing them to either local data, that is a mobile map package created in Pro, and that mobile map package should have a mobile geodatabase that has a transportation network. Or you can also point to a network analyst service, in particular an NA server service, and this is as opposed to a GP services. When using local data, the solve is done on the device using the runtime code, and when using services, solve creates a service request from your inputs, and the server does the server code does the solve and returns a result. So let's look a little bit deeper into the API. Now, one thing you can do with the API is your inputs can come from like tapping on a map and using the XY or geocoding locations, but we also support using a feature table. That feature table can be a service table, so something published to a portal, or it can come from a local geodatabase. So a workflow might be something like a back office person creates stops and exposes those as a service, or packages them up and syncs those to a device, and then a field worker can use that device and have a list of stops that they need to visit for the day. One thing to note about using tables is that we actually use the field attributes and try to match them to properties on the input objects. So for something like a stop, you might have a route name property, and we'll look for a field on those tables named route name and populate the property based upon the values in those fields. Now, inputs also have a number of settable properties, and setting some of these can influence how the solve is performed or what comes out of the solve. I'll just point out a few here. Like a stop has a route name, and what this does is it can group stops and produce a route result with multiple routes from a single solve. You should also set a unique name on each of the features. The reason being that solvers can return messages or an exception might happen, and in both cases, the information that comes back from those may include the names of the stops. So if you have unique values on it, it's much easier to figure out what's going on. You can add a cost to a stop, and that cost might represent the time to do work at a particular location. So adding this means that the route's total time will represent not just the travel time, but also time for servicing a stop. We also have something called current bearing and current bearing tolerance. Setting these can help determine which network edge and which side of a street a stop gets located on. You have to set them both for them to be used. Now, locating is the first phase in doing a solve. This is where we try to find out what network edge a particular location is closest to. We really attempt to locate stops. We assume that since you've added one, you want to use one. So we actually search out 20 kilometers looking for an edge to locate on. In most cases, that's probably enough to find an edge, but it's really dependent upon the network. So if the network has lots of restrictions, or it's a sparse network, or you're in a completely incorrect area, like you're using the wrong data set, we might not be able to locate. When using local data, one thing to note is that all the stops need to locate. And if they don't, you will get an exception. And then when using services, though, you will get a result back, but the result messages will include the fact that some locations were not located. When solving, you really should wrap your solve in a try-catch block and catch ArcGIS exceptions and/or ArcGIS web exceptions. The exceptions can give back more information regarding what happened. For example, ArcGIS exceptions has a numeric error code that is returned, and it can be helpful if you want to respond in some way to specific errors by looking at this particular error code. The URL below will give you more information on the errors that may be returned. And for ArcGIS web exceptions, the details property gives you more information on what happened, and you might want to do something like that, like present to the user or log it. As I said, a result object can have an array of message strings. So these are information the solver produces and brings back when the solve is complete. They might be warnings or errors, such as unlocated stops. And depending upon your app and your workflow and such, you might want to present these to the user. So after solving, you get back what I call our like routed stops or solve stops. These are a copy of the inputs, but now they have the read-only properties or some of the read-only properties populated. And there are a number of these, but let's just take a look at a couple. First, distance to network location. And as you recall, I said we search out 20 kilometers. The value that this particular property holds can tell you how far your input XYs are from where it got snapped to the network. And if that value is rather large, it might tell you something about that, your locations are off from what you expect. We also have a location status property that gets populated. This value gives you more information on what type of edge a input located. So it might have located on a closest edge, but it also there might be an edge closer, but it was restricted. So you might get something on the closest not restricted edge. And then services, as I said before, allow for not locating. So you might have a not locate status set or a not reach status set. Network location. Inputs also have a network location property, and associate with that is a source object position. The values for these are populated on solve, and they basically define the location by an edge ID and a percent along that edge. But these properties are also settable, and they can give you fine-grained control over locating. But to use them, you need to be very familiar with the network that you're locating on. So the process by which these properties are used are, first, the values are checked against the network being used to see if they are valid. And if they are, we use these for locating. And the XYs will just be ignored. If they're not okay, the locating will just fall back to using regular XYs. But it's important to note that these values are just strings and numbers, and the values can validate, but not necessarily be applicable to the current network. So you might have an edge ID of 100 on this network that you're using and another network where this was created on, but they might be in completely different locations. As I said before, it's very important to be very familiar with the network being used if you're going to use these properties. You can also get directions back, and directions actually have a lot of information in them. So for one, directions actually have geometry. They can either be points or lines. And the one thing to note, when a direction maneuver represents a stop, that is the snap to location of the stop. So that's opposed to the input XYs of that particular associated stop. So using the direction maneuvers, you can actually find out exactly where a particular stop snapped to. Maneuvers also have other useful information, such as the maneuver type, the ETA, and the duration of that particular maneuver. Now let's jump into a demo. Hi. In this demo, what we're going to do is we're going to look at using a table and a service table as inputs to a solve. Now, this is the data that we'll be using. This is a geodatabase I created and dropped some points in. If you notice, we have attributes here: name, route name, sequence, ATTR underscore travel time. These are attributes that will be respected and used as properties on the input features. I have taken this table and packaged it as a mobile map package and extracted it out the geodatabase in there to use in one part of the example. And then I've also published this using the sharing web map tool, creating a feature service in our portal. So if we look here, this is the feature service that I created, has similar attributes. So if we go to our code now, we can see started up the application. Now I can add stops from a geodatabase. This is just bringing in those stops, just reading the geodatabase directly and adding them as operational layer. And then when I solve, I could see that I get the attributes respected, because we can see that the fact that we have added costs and we have two routes, so those respecting the route name. Can't really notice it necessarily, but it actually is respecting the sequence values, since it goes from 1 to 2 to 3. Now, similarly, I could add those same stops that I publish as a service layer. And in this case, I bring them in, and we see that we've got the 3 stops here and 3 stops here. In this case, they're actually symbolized based upon the route name. Again, I could solve, and we get similar results, again showing that they respect the values on the table. I can also do a query or a solve with a query, and in this case I'm bringing in the stops based upon route name, which I've put here. So in this case, it's only going to solve, it's going to just bring in these, or I can change that to the other route and solve with a query. In that case, I'm solving on that one, or those 3 stops. I also created a file, simple CSV file with just a structure I made up, and I can add those. In this case, it's bringing in these 4 stops down here, and I could solve using these. This is actually graphics, and in this case, I've added a checkbox to decide if I want to take into account the costs that I have there in the CSV. So if I turn that on and solve, I could actually see that I'm now using the costs, because my total time has changed and my travel time has changed, or as compared to my travel time. So if I stop this and take a quick look at the code. So what we did is I'm actually just using the operational layer that I've added the data as for when I'm using a table of stops. And in this case, I can apply a query parameter if I want, but mainly when I'm setting the stops, I'm just setting it as a table. When I want to pull in the service, I've actually just used a query to pull down a service table from my portal area. And then at this point, I'm loading stops from a mobile geodatabase, basically just reading this geodatabase, finding the table, and then adding them to the map as a operational layer. So when I go to solve, I actually solve based upon pulling this table back out of the operational layer. When I'm using the graphics, this is when I'm using the file. I actually go in and read the graphic. I create graphics, and then when I want to use those graphics as stops, I read the graphics and I look at the graphic attribute properties. I've set those based upon the values in the CSV file, and then I set the stop properties based upon my graphic attributes, whether if they exist or not. In this demo, we're going to look at locating with tables. We're going to look at exceptions, and we're going to look at result messages. So if you recall, one of the things I said previously is that we look out 20 kilometers when trying to locate a stop. So if I see approximately how far 20 kilometers is, I can create a buffer at a particular location. Now, what I would expect that if I draw some stops in here, even in the water area, that it's going to look for an edge and try to snap to it. And those edges will be on the shore. So if I create a couple stops, and then I'm going to solve locally, I see that that's in fact what I get back. I've located to the shore with this one stop that's out in the water. Now you can notice that the distance to the network is rather large, so again, that's something you can maybe note, show the user, or do something within your application. Now, what I would expect when I'm doing a local solve, if I have something that's farther than 20 kilometers, is an exception. So if I drop something farther out and do a solve again, that's exactly what I get. An exception, an ArcGIS exception with an error code. So if I can look for this 5007 error code if I want to find unlocated stops. Now, if I use the similar data and do a solve using a service, I expect something different. In this particular case, I expect a result, but a solver message telling me a stop was unlocated. And that is what we get. Now, kind of a trick that I can do to look for unlocated stops is take each stop, use it as both the start and end, and then iterate through the stops and check the exception message in case there's a failure. I can do that for local data at least. So in this case, let's clear this route, and this is just a check. So I'm going to go through, and I've done multiple solves, and I've actually found that one of the stops as expected is unlocated, and I just report that back. Alternatively, I could do that something similar like to that, but I can just not use the stops that are unlocated and then use just the located stops to give me a route back. And we see that we get that back when I do code similar to that. So, and then finally, when using services, as we saw, the messages are what are returned, telling we have unlocated stops, but we do get a route. So in this case, I can actually just look at the returned stops and look at the location status to see if they're unlocated. So if I do that, I can just report a message in that particular case. So I've iterated through all the stops and shown, looked at the location status message and found that there was one that was unlocated. Now, if we actually look at some of the code that's associated with that, it's fairly simple. In this particular case, I'm just iterating through stops to create an unlocated stop dictionary, and if I get an error code of 507, I add it. Reporting service area ones, I just look through the returned routes and the returned stops and look for the location status of not located. And then finally, to actually solve using local data, I can create a do similar pattern, but whenever I get a unlocated stop error code, I don't include it in the list. Otherwise, I do include it in the list. Now let's look at the Navigation API. The Navigation API helps track your present location along a route. It takes in a location and raises events, providing voice guidance at key location, and it updates the internal state of the tracking object with each new location. One thing to note is it does require a route result containing a route that has directions. And the directions are needed because this is where the voice guidance are generated from. Now, rerouting is something that it can do automatically when off route, but this is optional, so it doesn't have to be set. Off route uses a distance in the current bearing versus the route's path bearing to determine if off route. So it uses 32 meters if moving along a segment, so that is the bearing's the same, or 16 meters if moving away from a segment, that is the bearing is different. When rerouting, we actually support 3 different strategies. That's to next waypoint, to next stop, or resequence stops. In each case, these strategies just define what stops or waypoints can be dropped or how they can be manipulated. But just to be clear, it is doing a full resolve, not just up to the next particular stop. Note, if using a service, you also must be able to set the license for automatic rerouting option on the service. This allows the route tracker to call the service when rerouting is needed. Voice guidance. When voice guidance is generated, it takes into account a number of things. The text length of the guidance itself to help determine how much time is needed to enunciate, the speed of travel and the distance to the next maneuver to determine how much time is available, and where you are relative to the current maneuver and the next maneuver. Using these factors, it can produce different types of notifications, that is, different types of voice guidance, long, middle, or short. Long being the full text of the guidance, middle being a pared down version, and short being a very brief version of the guidance. Also note, when creating voice guidance, the API might expand out abbreviations. So something like ST period gets changed to street when being enunciated. Also, the voice guidance does some rounding of the values and tries to be more similar to how a person would give an instruction. So it wouldn't say something like in 1.45 miles, take a right. It would be changed into a mile and a half, take a right. The event we provide is based upon raising new voice guidance at key locations along a maneuver, such as at the start or near the end. The event might also collapse a series of very short maneuvers into one voice guidance events, like turn right then left. But the API also allows you to generate voice guidance as needed. So this might be via a UI interaction where a user wants the voice guidance to be repeated. But you could also check, let's say, the destination or maneuver distance and generate voice guidance as you see fit. Tracking status. With each coming input GPS location, a new tracking status event is raised, returning a new tracking status object. The object contains the latest information regarding the state of the object along the route. This object has several pieces of information, and I'll just point out a few here that might be less obvious. The current maneuver index. This allows you to take to get the directions text associated with the current maneuver. This could be displayed to the user. It also might be used to get the next directions text, which you might want to show to the user so that they know what's coming up. Tracking progress. This gives the state of the current location relative to the current maneuver, the next destination, or the overall route. The display location. This differs from the GPS location, that is the value that came in the fact that it's snapped to the route and its bearing is aligned to the route path. Now let's do a demo. This demo is going to cover the navigation API. So the first thing I'm going to do is I'm going to drop a couple stops. I'm going to put them fairly close together just so we're not watching it track a route for a long period of time. I'm going to solve, and that gives me a route result object back. I'm going to create a route tracker object from that route result. That's just doing that in the background, but it's hydrating the route tracker object based upon the route result. And then I'm going to follow this route, simulating GPS. I'm going to use the regular API voice guidance event, and it's going to enunciate information as we move along this route. Once I start it going, it's going to start saying our voice guidance, so I'll be kind of silent for a second.
Go east on West 5th Street toward North Louise Avenue. In 450 meters, the destination is on the left.
Okay, between these voice guidance, I'm going to point out a few things, such as printing out the voice guidance information up here, the last one we got.
In 200 meters, the destination is on the left.
I'm showing information over here, such as the destination progress and route progress. What's left?
In 100 meters, the destination is on the left.
I'm going to let it continue to the end.
You have arrived on your left.
Okay. One thing to note too, I've taken the directions guidance, the directions text, and printed it out here, and I've been highlighting it as we move through the route itself using the tracking status, current maneuver index, and using that value to figure out which part of the array I should be on at that point. So I'm going to switch over from this to something what I'm calling like my voice guidance in this API in the UI. This is going to be different from the actual API event in the sense that instead of hooking up the API event, what I'm doing is I'm just looking at the tracking progress information and using a distance-based value to decide when to give some sort of information back. I'm not using the actual voice guidance itself. I could, but I just did this so it could be more obvious that we're doing something different here. So I'm going to create the route tracker object again. Then we're going to start at the beginning.
Go east on West 5th Street toward North Louise Avenue. Go east on West 5th Street toward North Louise Avenue.
So it's set it at 500 meters, which just happened a second ago. It's set at the very beginning also. And it will say at 250. I'm going to point out a couple other things here in between there. I can also just request information based upon the tracking status object and enunciate it, like time remaining.
Remaining route distance is 300 meters. Time to next destination 1 minute.
And distance.
250 meters to go.
So it just passed that. I can actually ask for the regular voice guidance, so it generate the voice guidance from the tracking status object, or the route tracker object.
In 150 meters, the destination is on the left.
And we should hit at 50 meters, it should say it again.
50 meters to go. At stop.
So we've covered a few things. This is the tracking, the route tracker object that we've hydrated from route result, and we followed it, and we've enunciated the directions using both the voice guidance event and our particular not event, but information based upon the tracking status progress and how long we are to the next destination. Now let's look at some related topics. Route layers are a mechanism to store and share routes across the ArcGIS platform. They store a solved route along with the analysis setting used to create that route. Route layers can be created in Pro or online tools, or they can be output from Python scripts. They are stored and shared on a portal as a route layer portal item. Multiple Esri products, including Runtime, can consume these items. Using a route layer. As previously mentioned, a route layer has both a solved route and analysis settings. In Runtime, we can extract out the solved route to create a route result. This is done via the create route result async static method. The route result at this point is independent of the transportation network, so it can be visualized or navigated upon without access to a network data set. The analysis settings, though, can be extracted into a parameters object using the create parameters async method. In this case, it requires a route task object and hence a network data set. When the route parameters object is created, it will validate the costs and restrictions against the route tasks network dataset. If all the costs and restrictions can be matched up, the route parameters object will have a matching travel mode. If not, it will fall back to use the default travel mode of the network dataset. So it's important when using route layers that the app consuming them is using a network dataset that is the same or similar to the one that was used to create the route layer. Location data sources can be connected to a map's view location display, providing it with the current XY location. Runtime provides a simulated location data source that will simulate incoming locations based upon polyline or an array of locations. This can be used for testing or demoing. Runtime also provides a route tracker location data source to allow a maps view location display to be connected to the route tracker's display location, which snaps the current location to the route and aligns the bearing to the route path, thereby eliminating some of the potential wandering of incoming GPS locations. In this demo, we're going to look at the difference between using raw GPS points and using the route tracker location data source. So the first thing I'll do is add some stops, and then I'm going to solve. Gives me this route back. I'm going to add what are GPS points that I'm simulating. So I've created a line and simulated the GPS points that would be used to produce this line. So next, I'm going to create a route tracker object in the background, and then I'm going to use the regular GPS points, the red points here, as my maps use location data source, display location. And what we see here is what we expect. It's going to follow those those points and basically that line, and not necessarily be tracking the route that we would like to be tracking. So if I stop that, and instead of using these points directly, I'm going to use the route tracker location data source where I pass these points into it. What that does then is use the display location coming back from the route tracker, and the map view will then show that as its display location. So this is what we're doing here. As you see, we're following the route line. Now the code isn't actually just using the route line to follow as a path. It's actually taking the simulated points and then pulling out the display location coming back from the route or from the tracking status object and using that as the map view's display location. So if we stop this and look at the code, it's merely a difference of using the route tracker location data source as your display location, or using the simulated location data source directly as your location display. This demo is going to look at a route layer and using it for navigation. The first thing I'm going to do is switch my map. Right now I'm in the LA area using local data, but I'm going to switch over to an online map. This online map is in the Boston area. Next, I'm going to download a portal item. So that's this. And what it's done is it's pulled that portal item down, which is actually just JSON data, and saved it locally. It's something I created earlier and saved a portal, which we can see here is this is the item I've downloaded, and it's a route around Boston area. I can display that portal item. And then next, what I'm going to do is load it as a route result. If you recall, what that means is I'm going to pull out the directions, stops, and actual route, and make a route result object. I've displayed that, got the line out, and put the stops on the map. I've also pulled out the directions, and I've displayed some of the information regarding that route. Next, I'm going to create a route tracker object. Route tracker object to do rerouting requires a route task. Since I'm right now not using local data and I, let's say, don't have access to a service, I'm not actually going to be able to reroute when I use this route layer. All I can do is follow the route or not follow the route. Once I'm off, I can't do automatic rerouting. But I also just don't have any data to do that with, so I'm going to have to make do with what I have, I guess. So I'm going to create a route tracker object, and it's going to, I have a message going to warn me that I actually can't do rerouting. But what I can do is actually track this route. So if I use the route as the GPS points,
Turn right on Union Street.
as long as I stay on this route,
In 250 meters, turn right on Lindy Street.
I can actually use it without having a network data set, and I actually have no data on that I'm using. I'm just using a web map right now. The only data that I actually have access to is the route layer itself, the JSON.
Turn right on Lindy Street.
It works similar to our previous demo in the fact that
Bear right on New Rutherford Avenue.
it's giving us voice guidance and giving us information of traveling along the route. So this could be a very lightweight application.
Continue forward on Rutherford Avenue.
As long as you don't mind.
Continue on New Rutherford Avenue. Continue on Rutherford Avenue.
We're going to stop that. As you don't mind not being able to reroute. All right, let's do a quick summary. We looked at the fact that the API supports feature tables for inputs. We examined the properties of stops or inputs that we could set and how it affects the ending result. We did some locating, seeing how it differs from local data versus services. We checked exception messages. We looked at the fact we have route result messages. We also looked at the stop properties after actually doing a solve. And then we looked at the network location field and how our property and how it might affect your locating of features. And then we mentioned the fact that directions actually have a lot of information on them. Regarding the navigation API, we mentioned the fact that we can do automatic rerouting. We looked a little bit at voice guidance and tracking status properties. Then finally, we examined some related topics, which included route layers and location data sources, in particular the route tracking data source. That's the end. Thank you for your time.